So in evolutionary process model, we have to understand that the requirements are not frozen. Okay, requirements are something which often changes. New requirements keep on coming. Maybe because of business competition, or maybe because of government rules, or whatever the reasons may be. These requirements keep on changing. Also, there is a tight deadline that we want the system, working system within this particular time limit. Yeah, definitely they can prioritize their functionalities. Because of the priority what we have, because of the priority, we can make a incremental fashion where limited functionality can be introduced in first phase, right? So one thing is very clear, that it is not a simple software. For simple software like we will use waterfall model. This is not a simple software, it is a complex system. Okay, so it will have lot many features which may be interrelated to each other, so we will have to keep in mind all these things. Okay, one thing also we have to understand, that this business, this kind of system will definitely have certain core functionalities, that these functionalities are such which must be there. Okay, and others will be complementary functionalities, or other kind of functionalities which may keep changing. However, these core functionalities, core system requirements are those which will not change. This is the basis, this is the basic thing of our business. Okay, so in that case, evolutionary process models are very helpful. In this evolutionary process model, you will definitely have iterative kind of thing. Okay, you will perform certain operation, and you will perform set of operations, and you will perform them again. Now let me state two common evolutionary process models. First is prototyping model. So in this prototyping model, what is happening? Very simple. One thing we have to keep in mind, that here for prototyping model, when we are going to use, the thing is the customer or the client, they are aware of the core requirements of, I should say, the basic objective for which they are going to make this software. However, they may not be very confident in what are the actual features, what are the functionalities that they really want in their software, right? So for that purpose, what we have to do, we have to make a prototype for them. Prototype is a simple kind of software. The actual software will have these functionalities and all of them are working. However, in prototype, what you will have something which can be seen, that these are the functionalities. You will show these are the buttons. On the click event of this button, these things will happen, and these kind of things you will have. Here, while making this prototype, you will not implement all the best practices. Okay, you will somehow in a hurry make something to display to the clients, so that after seeing actual thing, they will get to know that okay, I want these features also. Apart from this, the other kind of features should also be there. Whatever the features they want, you can get out of those particular clients. So here what happens, you start with the communication. In communication, you try to find out the objective. These are the things that they want in the software, and with communication, you quickly plan it. Okay, you plan that what is how can we implement this, and you will have a quick design. Okay, so with this quick plan and quick design, this is for just the prototype. You will construct the prototype, and you will show this prototype to the customer. Now this prototype, when once seen by the customer, what will happen, they will understand that okay, these are the functionalities already given, and what are the next set of functionalities they want. So those next set of functionalities, they will note them down that these are the functionalities that we want, and in the next iteration again they will make a quick plan something and then show the prototype. Yeah, these are all the features final, these are the features that you want. Okay, after confirmation they may use a linear model that yes, after these are the confirmation, this may actually depend on the software and need that after here the requirements may be frozen, requirements may not be frozen. Okay, it will depend on the system and software. What is this? If the requirements are frozen, from here you can use a linear model that after the communication you will make a detailed plan, detailed design, construction, and then you can deploy. And you may also go for another iteration, like you will again make a plan and you can show it to them, show the prototype to them. This now, what do you think? All the requirements are covered here. Now the thing is, you have made the prototype. What you are going to do with this prototype? There are two things that you can do. Either you will throw this prototype away, or you will evolve the same prototype. Okay, means I should say some of the good practitioners have suggested that these prototypes that you build, they do not use best practices of software engineering. Because of that, these prototypes should be thrown away. We should not use these in the actual things. So according to this prototype, a new software should be built having all these features which are there in the prototype. This prototype should serve as a basis of requirement, that these are the requirements for the software, and the new software should be built. However, there are certain problems. What are the problems? That this prototype may have been built in a hurry, right? We haven't used good practices, so haphazardly we have used certain not so optimized algorithms have been used, and certain kind of these problems might be there. So keeping in this thing, if we suggest that totally new software should be built, then management may try to find out the cost, right? This much time we have wasted, this much effort we have wasted in making the prototype. Now if we are making a totally new software, then it will again take that much effort and cost. So is it possible to make certain changes in this prototype and fix the faults and errors here and make it usable? So because of this, what happens, usually these prototypes are evolved and made as this thing, a final product. So it may remain with certain faults and these things. So this thing, when we will see something about agile methodology, we will try to learn to use good practices while making the prototype, so that this prototype can be used and need not be thrown away. Okay, so these are the few things that we have to understand about prototyping paradism. Apart from prototyping, there is something called spiral model. So here in a spiral model, we have to understand that it is also iterative in nature, but also uses controlled and systematic approach. Okay, in each iteration they are going through these activities: communication, planning, modeling, construction, and deployment. So this may take a little longer time than the prototyping. However, the softwares are the developers will have confidence in the software that in each iteration we have followed the systematic approach. We have communicated, then planned, made the estimation and schedules, these all the things, and modeling, perform the modeling, design analysis, and then coded and tested. After that, the increment has been delivered. Now, you may try to contrast it with the incremental model, right? In incremental model, what happened? While it has not completed one cycle, in between the next increment, working on next increment has already started, right? However, in this spiral model, once one iteration is complete, after that the new iteration starts. Okay? One cycle is complete, then the next cycle starts in this spiral model. So, here also, because of this, since we are using this systematic approach, risk is less. Okay? Now, here also you will understand that since this is a spiral thing, in each iteration, in each cycle, I should say, in each cycle we are implementing some of the features, some of the new features, and maybe we are also adjusting for the changes in requirement and the new component, I would say, the new increment is introduced. One problem is here in planning. We actually do not know that for how long this spiral evolution will keep on going. Okay, the new changes will keep on coming, the new increments will keep on being built. So that may be a problem to plan and schedule and actually to estimate the cost, right? Apart from these spiral model and prototyping model, one thing that we can see is concurrent model. In concurrent model, what we are saying that there can be something going on parallelly. One thing that we have to understand, there are multiple activities in the development life cycle, right? These activities, as the 5 activities we have seen, let us consider this communication activity or planning activity, modeling activity, and construction activity. These are the activities. Here in this diagram we are showing just the modeling activity, where you can understand that we are saying that all the activities, all the framework activities, basically all the activities are in any one of the state. Either they are inactive while communication was going on, maybe modeling was in inactive state. So suppose now communication phase has completed and is waiting for certain changes. Okay, so it is waiting somewhere, no problem. Now modeling activity was inactive, and since communication has completed, now it has a transition has occurred from inactive to under development. Now this modeling activity is in under development stage. So from here there are 2 possibilities for this. Either under development, when it was in under development, new changes came in the requirement, so it went to the awaiting changes stage. Okay, or it may go to the, it may design, certain kind of designs may be done and it may go to under review. From here it may be either accepted that yes, it is done, or it may be baseline that okay, these are the few things that are totally good, some of the things that can be done. Whatever all the changes are done, and then it can be accepted. They are in done state. After doing, they can again go to waiting for changes, this stage. So these are all the possibilities. If certain changes come sometimes, though, then they can be revised again, then they can be reviewed and done. So these are certain states in which they can all the activities can be. So if we are designing, if we are using this process of development of software, where we are keeping track of all the activities going on, all the activities are in a certain state. So we can say that all the activities are running on concurrently for this particular project. Okay, so we are calling it as concurrent models, that all the activities are running, and they may be, some of them might be in awaiting changes state. Okay, first of all, initially they were in inactive state. However, after inactive, they will start under development, or they will be in awaiting changes. After done, they will be in awaiting changes state. Okay. So this was something about concurrent models. So in this way we have understood that these are the evolutionary processes. So in these evolutionary processes, one thing we have to understand that the system was complex, and we want the few of the requirements to be delivered quickly. So we have seen prototyping model or spiral model. Concurrent models can be also considered as evolutionary one. However, you can also see that there can be certain problems. What was the problem? That suppose we are using prototyping. There also you are not certain about the number of cycles will be required. Here in evolutionary also, you do not, evolutionary spiral also, you do not know how many cycles it will require. So you will not be able to estimate actually neither the time nor the cost. So that is the problem. Now speed may also be a problem, that at what speed you want to develop the software, how fast you want to go. Because if you are at top speed, you are moving too fast in that, then what may happen? You may lead to chaos. Okay, where many of the things are done haphazardly. However, if you are too slow, then it may not be good for software development on time. So, keeping these things in mind, there you have to decide which models should be chosen accordingly. If at all, definitely they are complex systems, then evolutionary approaches are the one which should be used. Next we will try to see some other model, and also agile development is there. Okay, thank you.